नमस्ते दोस्तों, बाडाल दिस साइड और आज हम एक्सप्लोर करेंगे एक ऐसे इंटरेस्टिंग टॉपिक को जिसके बारे में बहुत से लोग जानना चाहते हैं। न्यूक्लियर रिएक्टर से बिजली कैसे बनती है। एएपी में से बहुत से लोग न्यूक्लियर एनर्जी के बारे में सुनते होंगे, लेकिन क्या आपने कभी सोचा है कि यह कैसे प्रोड्यूस होती है? कैसे एक न्यूक्लियर रिएक्टर जो कि कॉम्प्लिकेटेड मशीनरी से भरा होता है, हुमेन वो इलेक्ट्रिकल एनर्जी प्रोवाइड करता है जिसे हम अपने घरों में लाइट्स जला पटे हैं, अपने डिवाइसेस चार्ज कर पटे हैं और अपनी रोजमर्रा की जिंदगी में यूज करते हैं। चलिए अब न्यूक्लियर पावर प्लांट और रिएक्टर से इलेक्ट्रिसिटी जनरेट होने का प्रोसेस बहुत ज्यादा डिटेल में समझते हैं। To understand how a nuclear reactor generates electricity, we first need to understand the fascinating process of nuclear fission. Imagine a tiny atom of uranium-235, a radioactive element. Now picture a neutron, a subatomic particle, colliding with this uranium atom. This collision causes the uranium atom to split into smaller atoms, releasing a tremendous amount of energy in the form of heat and more neutrons. These newly released neutrons then go on to collide with other uranium atoms, causing a chain reaction. This chain reaction, like a controlled explosion, is the heart of a nuclear reactor. It's like a game of billiards on an atomic scale, with each collision releasing more and more energy. The beauty of this process lies in its efficiency. A small amount of uranium can generate a massive amount of heat through fission, far more than burning fossil fuels. Now you might be wondering, how do we control this powerful chain reaction? That's where fuel rods and control rods come into play. Imagine fuel rods as long cylindrical tubes packed with uranium pellets. These rods are carefully placed within the reactor core, where the fission process takes place. Control rods, on the other hand, are like the brakes of a car. They are made of materials that absorb neutrons, effectively slowing down or even stopping the fission chain reaction. By carefully inserting or withdrawing these control rods, we can control the rate of fission and therefore the amount of heat generated. This delicate balance between fuel rods and control rods is crucial for the safe and efficient operation of a nuclear reactor. It's like a dance between unleashing the power of the atom and keeping it in check. The immense heat generated by nuclear fission needs to be harnessed and transformed into something useful: electricity. This is where water comes into the picture. Inside the reactor, there's a closed loop of water circulating around the reactor core. As the water flows past the fuel rods, it absorbs the heat generated by fission. This heat causes the water to boil and turn into high-pressure steam. Think of it like a pressure cooker, but on a much larger scale. This steam, now carrying the energy released from nuclear fission, is ready to embark on its journey to generate electricity. Chapter 4: Spinning to Life. The turbine's role. The high-pressure steam, brimming with energy, is then channeled towards a turbine. Imagine a turbine as a giant fan with rows of carefully angled blades. As the steam rushes past these blades, it causes the turbine to spin rapidly. This spinning motion is the key to converting the steam's thermal energy into mechanical energy. It's like the wind pushing a windmill, but instead of wind, we have powerful jets of steam. This mechanical energy is the driving force behind the next stage of electricity generation. Chapter 5: The Magic of Electromagnetism. Generating electricity. The rapidly spinning turbine is connected to a generator, the heart of electricity production. Inside the generator, a magnetic field interacts with coils of wire. As the turbine spins, it rotates the magnets within the generator. This rotation induces a flow of electrons in the wires, which is essentially what electricity is. It's like magic, but instead of spells, we have the laws of physics at work. This newly generated electricity is then ready to be distributed to homes, businesses, and industries. Chapter 6: The cycle continues. Cooling and condensation. After spinning the turbine, the steam, now devoid of most of its energy, needs to be cooled down and converted back into water. This is where the condenser comes in. The condenser is like a giant cooling tower, where the steam comes into contact with cold water from a separate source. This causes the steam to condense back into liquid water. This condensed water is then pumped back into the reactor to absorb more heat. completing the cycle. It's a sustainable process, ensuring the continuous operation of the power plant. The electricity generated by the nuclear power plant is initially at a lower voltage. To transmit this electricity efficiently over long distances, it needs to be stepped up to a much higher voltage. This is done using transformers, which are like electrical gearboxes. They increase the voltage of electricity, reducing energy loss during transmission. Once the electricity reaches its destination, it's stepped down to a lower voltage suitable for household and industrial use. This ensures that we receive electricity at a safe and usable level. Nuclear reactors are designed with multiple layers of safety features to prevent accidents and protect the environment. The reactor core is housed within a thick, reinforced concrete containment structure, capable of withstanding extreme pressure and preventing the release of radioactive material. Sophisticated control systems constantly monitor the reactor's parameters, ensuring that the fission process remains stable and under control. In case of any anomaly, automatic safety mechanisms shut down the reactor, preventing any potential hazards. Furthermore, radioactive waste generated during the process is carefully managed and stored in specialized facilities to minimize environmental impact. दो न्यूक्लियर पावर प्लांट में यूरेनियम 235 के फिशन रिएक्शन से हीट जनरेट होती है, जिसे वाटर को स्टीम में कन्वर्ट किया जाता है। यह स्टीम टरबाइन को रोटेट करते हुए मैकेनिकल एनर्जी जनरेट करती है, जो जनरेटर को ड्राइव करने का काम करती है और इलेक्ट्रिसिटी प्रोड्यूस होती है। इस इलेक्ट्रिसिटी को लॉन्ग डिस्टेंस तक भेजने के लिए हाई वोल्टेज यूज होता है। ये प्रोसेस क्लीन और एफिशिएंट एनर्जी प्रोवाइड करता है, लेकिन इसमें सेफ्टी और रेडियोएक्टिव वेस्ट मैनेजमेंट काफी जरूरी होता है। आपको कोई और स्टेप या स्पेसिफिक पार्ट क्लियर करना हो तो बताइए। होपफुली अब आप समझ गए होंगे कि कैसे एक न्यूक्लियर रिएक्टर, जो कि कॉम्प्लिकेटेड मशीनरी से बना होता है, हुमैन, वो इलेक्ट्रिकल एनर्जी प्रोवाइड करता है जिससे हम अपनी जिंदगी आसानी से जी पाते हैं। न्यूक्लियर एनर्जी एक कॉम्प्लेक्स टॉपिक है, लेकिन यह समझना इंपॉर्टेंट है क्योंकि यह फ्यूचर में एनर्जी का एक इंपॉर्टेंट सोर्स बन सकती है। थैंक्स फॉर वॉचिंग। प्लीज सब्सक्राइब ब्रेन ब्लूम चैनल फॉर सच इंटरेस्टिंग एंड इंफॉर्मेटिव वीडियोस।